Wow, I have to follow that guy. I should have had some coffees or something before. Wow. Has anybody here heard of the company Terramark before? Okay, that's a good start. So, Trapezoid was founded by a group of guys who were working in the security space at Terramark. Terramark was kind of a pioneer in the cloud services for high security folks like federal agencies, things like that. They actually had a very large FISMA compliant data center that they operated out of Culpeper, Virginia, that they were pretty well known for. And the founding folks at Trapezoid were the folks that built the tools for that data center. Verizon purchased Terramark a couple years ago, and some of the innovation sort of slowed down a little bit. And so these guys left the company to go out on and start this company to continue building those tools. They had gotten a lot of feedback from the federal agencies and a few of the high security industries like financial services and infrastructure. And they kind of knew what was missing in the security space for virtualized infrastructures and things like that. So traditionally they were building the typical tools that you all probably use in your enterprises. It's the best of breed kind of standard approach to risk mitigation in a security environment, and these are necessary tools. But what they realized is, and they had heard from the Fed and a few agency, high security companies, is that there were problems around another area, or we had forgotten an area to look, and that's underneath. So what we forget is that our software actually runs on software. When you boot a machine the first time, whether it's a server or a client or your mobile phone, the first thing that boots is some sort of ROM or a BIOS or something like that. And then after that, it'll talk to some small modules that'll initialize peripherals and a few other things. And eventually, the master boot record. And all these things happen before the general purpose operating system is loaded. So we've been spending all this time working on all of these things, and we've got this covered. We've made the attack surface difficult for the bad guys here. So where did they go, right? So they found the one that we forgot about. So I'll just roll these out. So traditionally, we, in a virtualized environment, we've pretty much taken care of things here with our current tools, right? We've got tools to secure our VMs. We've got tools to secure the operating system, OS, and even in the network layer, we have those. But what if something was compromised below that layer? So keep in mind that the BIOS actually acts, once it's booted, it actually acts as sort of a proxy between the general purpose operating system, whether that's a hypervisor or a regular OS, and all the things on the machine. That's the memory, the disk writes. And so if someone were to compromise at this layer, they could basically lie to everything above it and mitigate all of the investment that you've made, right? So this slide is really just to illustrate that, and I already mentioned this, that not only just your servers and workstations, but your routers and your switches, they all have the same concern, right? Across the entire data infrastructure. So what kind of attacks are occurring? This is just some I threw together real quick about some attacks that are happening at this layer over the last couple years. Some of these have been presented in Black Hat or DEF CON in the last couple years. Who attends that show? Anybody here go to any of those shows? One guy, two guys, right? So those guys usually go out and they'll take some forward-looking stuff and demonstrate it. Like, for instance, the Rakshasa was one that was not only a bootkit that took over the BIOS, but it was persistent. So if you somehow figured out that your BIOS was compromised and flashed it, it would replace itself using another ROM. And the other thing I wanted to mention here is that there's a few open source projects that actually build BIOSes. And this is probably a good thing. If you want to make something custom in your BIOS and flash your BIOS with an open source project, you can do that. The downside from a security perspective is it provides a platform for development for the bad guys to deliver their payload. And then also, some of the BIOS companies haven't done a very good job securing their BIOS source code. AMI is one of the larger BIOS companies out there. Their source code was found on a Thai server, I believe, in Taiwan. And it was in addition to their private key, which means not only could someone reconstitute an AMI BIOS that looked completely legitimate to your administrators, but they could sign it with the private key that was AMI's private key for some time, and that affected hundreds of thousands of server blades. In addition to the actual hacker threat, there is, and you may be familiar with this, a supply chain concern as well. So, Dell manufactures or designs a board in Austin, Texas, or wherever they're designing those, and they send those schematics off to a manufacturing plant. And the schematics will say things like, draw these wires, put these chips here, and then when you're done, put this software on these little chips. And they provide them some ROMs, right, to put on there. Unfortunately, a lot of times there's no full circle check on that, and those boards may go out with ROMs other than what Dell had intended. And that had been the case in a number of build slides. In a number of public kind of embarrassing events where stuff has ended up commercially on the shelf, already compromised. So supply chain is also a threat vector. So what does Trapezoid do to solve these problems? So primarily we're sort of operationalizing a few tools that exist on the servers today. Who's familiar with the Trusted Computing Group? Wow, of course you are, yeah. So the Trusted Computing Group, real quick, is a small standards body. They had written a number of recommendations around how to mitigate this threat years ago. And it's been incorporated into a lot of the boards on servers and things that we use today. Companies like Intel are also building tools to mitigate this. The problem is that those tools are difficult to operationalize in an environment. So that's what we do. We actually dig down into those ROMs and into those chipsets and feed that data into your security ecosystem. One other problem that these tools give us a chance to address is if you're a large company who's leveraging the public cloud, say to maybe burst to do large data processing on demand, and maybe you have some regulatory concerns. What we heard from clients was, especially in the financial services area, was, look, I would like to burst into a public cloud provider just for a small time when I need it, and then retract. Except I'm concerned about that because when I go into the public cloud, I don't know where my data actually is. It's out there. They've got data centers all over the world. They may do a disaster recovery exercise and it ends up in Buenos Aires for an hour. I don't know. And I need to be able to answer to my auditors and things like that about where my data is residing from a compliance perspective. So using those same tools, we can do things like cryptographically tie a virtual machine to a physical location or physical machine. So just real quick about where we're at today. Primarily today, we're focusing on virtualization server layer and client devices. And we're taking the data that we get from those and we're feeding those into your forensics, GRC, SIEM tools so that you can write policy and incident response around those. We're moving into network and storage and mobile devices is on the roadmap. So I'm going to try to do the demo. The trick with my demo, and the demo gods, I prayed to them this morning, is that it involves a bunch of virtual infrastructure, and it's in San Francisco being used right now at the Intel Developers Forum by a bunch of my guys. So they're on the WebEx, and what I'm going to try to show is an application of where you can use this type of technology to build. Guys, can you mute? They're listening. How you could use this technology in a real-world application. So let me just go to WebEx here. So there should be a trusted user device. So I'm going to go ahead and pass the ball to the trusted user device. Can I do that? Yeah. Is that okay with you guys? Okay. Okay, so what the trusted user device is going to be is it's a laptop that has some of this technology on it in the field, and it's going to be attempting to, you can see it here, but you can't see it there, so let me just go ahead and drag that over there. Sorry, be patient with me while I do all these logistics. Oh, that's huge. All right. I hit close enough. So this is a web browser on a client device. It's accessing a web application. Let's see, it's a medical application for illustration purposes. And how am I doing on time? Good. Okay. So for illustration purposes, they've logged in as a credentialed user. And this is awesome to be able to do this on this large screen. Well, it's not working. I'm scrolling right now, but it's not doing it. Let me see if I can resize this. So what I need to do, bring it over here, make it really small. It's better. It's not any better, is it?
Control minus.
What's that? Control minus?
Once you put it up here.
Okay, hold on. I'm not seeing the whole screen for some reason. Oh, there we go. Okay. See if we can see it. So I'm just going to try to put it, oh man. So the demo guides are not on my side today. Control minus, you said I'm trusting you. I'm going to do this, see what happens. Nothing.
Yeah, it takes a little bit of.
Okay. It's a little bit better, but you can't actually see where I'm. There's a window down here that you need to see that you can't see. So what I'll do, let me just go back to slides because I have slides on this, and we'll abort using. Sorry guys in California who. They did it for me. There we go. So, there's a little window down here that pops up. So what this window is doing, and you can't see all of it, is when the user logged into this app, it took their user credentials. And then the actual Intel chip on their workstation did a check of their system. It created a one-time password, so you guys are familiar with like Secure ID and things like that. Well, this would actually do two things. It would, one, cryptographically identify the device as a corporate asset with a unique identifier, and then create a one-time password in conjunction with their application transaction. So you wouldn't need to carry around the fob anymore. Your workstation is the fob, and your Intel CPU is doing that for you. And then if the server that it's connecting to is also running in a trusted boot status, you'll get green, and the person can see all of the data. And now I'm going to try to do the same thing with another host. So hold on a second. How do I get the WebEx back here? There we go. Can somebody make the untrusted user the presenter? They've got the ball. So while they do that, so the idea is if the host connects and one of those parameters is messed up, whether they get their user credentials wrong, they won't get into the app. The one-time password is offset for some reason, they won't get into the app. If they did, okay, good. If they're able to get there. You can see down here at the bottom here that you've got yellow here. Maybe they'll click that for me, I'm not sure. But this means that they didn't pass the trusted boot. So that means the last time they booted up, the Intel checked all of their ROMs and found that one of the ROMs was modified from a known good status. So someone had installed a bootkit or something like, there we go, had installed a bootkit or something like that on the host. And as a result, they'll get redacted data on the actual server application. Does that make sense, everybody? So this is a common application of using trusted computing in a real-world environment from a client-server perspective. And if you look at it from a chain of trust, you're looking at not just the workstation, but also on the server side. So for instance, if someone had taken that server and it's in a trusted zone, so it's in a data center that we've approved, and it has passed all of the trusted boot status or anything like that, they'll get green. If someone vMotions that server or moves it, or zMotions if you're using Zen, to another data center which is no longer trusted, or a set of hardware that's no longer trusted, this would be yellow or red, and they wouldn't allow the transaction on the server side, right? So very high security applications, maybe with PII or government data. So that's that. And I have only 2 minutes left to show you. I'm going to show a dashboard, and he was just smashing dashboards, but I'm going to show a dashboard. So what we've done is, so I need to move it back to trusted user. There we go. So what we've done is we've tried to take all of these tools that are inside your computers in your virtual infrastructure and operationalize them into tools that you use to write policy and things like that. So these are going to be huge on the screen. So first I'm going to bring over here, this is, oh my God. Yeah, a little bit. Let me do a control minus and see if it works here. So this is a McAfee. I'm sure everybody's familiar with McAfee. This is a McAfee ePolicy Orchestrator dashboard. So McAfee has given us a bunch of APIs and allowed us to write code inside their management console so that they can create policy and write policy around these things. So for instance, if a server is untrusted and you move it to a zone, it has a McAfee agent, it'll shut it down, or something like that. As well as generate alerts and capture all of that data about the host. Give you an example of, we can actually create sort of a dossier, if you will, about a VM's existence in the cloud. So what servers has it been on, what locations has it been at, and you can run a report on that. And I actually have another one, but they're all going to look kind of like this, so I'll spare you. But we also integrate with your commercial SIEM products, so that's your security event management products. Like McAfee ESM is the one I was going to show, but we work with ArcSight and a number of others because we use a common format. So you can create an incident response around the security elements that we're providing. I think that's it. So does anybody have any questions? I'm sure. Oh, they did it for me. Here's the ESM.
Over here.
Yep.
So trusted devices, you talk about Intel, right? So we're talking about phones, laptops, we're talking about physical hardware or virtualized hardware. Where does it start and end?
So that's a great question. So when I'm talking about Intel, I'm talking primarily about clients and server hardware and their ROMs, right? When I talk about virtualization, we're talking about the layer applying that security to the layer above it. So taking that information that exists below the actual hypervisor layer and feeding it up into the ecosystem. For mobile phones and mobile devices, routers and switches, that is something that we're working on. It's not specific to Intel, but there's technologies in those as well that do similar things. Our first go-to-market was just the virtual infrastructure side.
ARM and AMD, or just?
So we're talking to everybody, and we've got partnerships. So before the company started, just probably a little context. Before we built the product, I should say, the company lasted for about a year just doing consulting for the OEM manufacturers around how to even enable this on their platforms. So our guys literally wrote the manuals for a number of the OEMs on how to turn this on. Intel built it, but Lenovo didn't know how to turn it on, and so we helped them do that. So we have a lot of intelligence around the inner underpinnings of the system. Yep.
Does it have capability of detecting if it's been spoofed, if somebody cloned that ESN and the IP address, the MAC address of the device?
When you say ESN, that's like mobile phone type stuff?
Serial number.
Oh, like a serial number? I mean, all it really can do is, from a detection standpoint, is uniquely identify and make sure none of the ROMs have been messed with or manipulated in any way, right? So it's not. I'm not sure what level of spoofing could go on there. If someone were to, put a false BIOS or put a false ROM on there, certainly that's what its core focus is. I don't know if that answered your question, but yeah. Yep.
Why isn't McAfee doing this?
So that's interesting. I'm not sure the answer to that question, but they actually partner closely with us. We're part of their SIA partner program, and their reps actually get paid to sell our tool as part of their suite. So they are doing it, but they're letting us do the heavy lifting.
Well, I just want to commend you. I was part of the wider Intel finance team when we used McAfee.
Oh, okay.
And it was largely because exactly what you said, virus scans can't detect below the OS and
Right.
stuff for you. It's the viruses that no one can address.
Right. Right. Exactly. Well, thank you. But yeah, that's exactly what we thought too. We thought, I can't believe nobody's looking at this, and there's a known issue. So, and like you said, nobody else was really addressing it. So we saw a pretty clear gap. Is that it? Thank you.